Alright, YouTube, back again, slowing the smart meter at night this time. I'm going to try and get power out of a battery bank. This is a used battery bank, of course. All the batteries are mismatched. I'm not sure how old they are, but they seem to hold a charge. Good enough for testing. And what I'm going to do is I'm going to do a few different tests using different gauge wire. Right now it's hooked up to, this is 4 gauge. Battery cable. What's running to my solar panels is this stuff. This is 10 gauge. Now on this I also have 10 gauge wire. That'll be a different demonstration. What I'll do is I'll compare how much it chokes off the amps. And the first test will be one battery. I got a little power meter hooked up here and it's showing 95%, and that's off a battery back there. So let's turn this thing on and see what happens. Alright. We're getting about 40 watts at a half an amp. Running one 12-volt battery off a 4 gauge wire through a 500 watt 10 to 30 volt grid tie inverter. Alright, now we have 2 batteries hooked up in parallel. The meter is reading 89%. Oh, before on the single battery I did, it was reading 89% running. Alright, let's turn it on, see what happens. Alright, watts, 40 watts, half an amp, okay, it's holding steady at 89, it's not dropping at all. That's 2 batteries hooked up in parallel. Gives me pretty much the same results as my first one. Alright, now we'll hook them up in series. Alright, I have these hooked up in series, so it should be 24 volts, and if I put my meter across both batteries, this thing is reading 100%. Alright, so let's turn her on and see what happens. Oh, the blinking lights are moving much faster. Big difference. 345 watts at almost 3 amps. $340 watts. Alright, we're gonna do next is we're gonna do the 10 gauge, see what happens. Alright, here we have a 10 gauge going to 1 battery. Let's turn it on, see what happens. Alright, 34 watts, 33 watts. Amps are pretty much the same. Okay, a little lower wattage, but that's from this front battery. You know what? I'll do it on the back battery just to be fair. Alright, now I got them hooked up to the back battery, which is what I should have did in the first place. Turning it on. Okay, this is the same as the first results. That'll settle down to 39. Which is the same with the 4 gauge wire. Amps, yep, pretty much the same. Alright, with 1 battery, 10 gauge or 4 gauge really doesn't make a difference. It doesn't seem to anyway. And what I'll do now is I'll hook them up parallel. Alright, here we go. 2 batteries hooked up parallel. Let's turn it on. Alright, it shouldn't make a difference. watts. Okay, it don't make a difference. I'm gonna hook them up in series next. We should probably see a difference when I hook them up in series, because this is a lot thinner. Alright, now I got the 2 batteries wired in series with 10 gauge wire. Turn it on and see what happens. Okay. Let's let it settle down a little bit. Before we had 340 watts. Okay, now we only have 300. Looks like it's gonna, well, we'll give it a little bit yet. Check the amps. Okay, before we had 2.88 amps with the 6 gauge or 4 gauge wire. Now we're down a little bit on the amps. Watts, I guess we'll take it there. 322. So I'm losing, looks like 18 watts going with the thinner wire. Doesn't really seem to be heating up that much. Heating up at all, actually. So it's pretty cool. Of course, then again, leaving it on like that, it might be a lot cooler. But being only a 500 watt grid tie, I don't think I want to go too much higher than what I'm doing now. Alright, now I have 3 batteries hooked up in parallel with the 10 gauge wire. See what happens. Okay. Watts. Alright, same as 1 battery, same as 2 batteries. Oop. Watts. Alright. Same thing. I guess we'll try it with the 6 gauge. Alright. Before I run a parallel 4 gauge wire, I wanted to, as long as I got the 10 gauge hooked up, I wanted to run 3 batteries in series, giving me 36 volts, but I had to switch grid ties. I have to use this one. This one was actually an AC input, so I had to remove the rectifier and actually bypass it, and the outputs now go straight to the DC output. So we put this together, see what happens. I also wanted to add before the phone rang, why would anyone run 10 gauge? No one does that because it chokes off the amps and watts, as everyone knows, but it's to see how far we can get with it. It's just a test. And if you look at these grid ties, you'll notice where you hook your big fat battery cable up to. On the other side is small wires. Once again, choking off amps. And if you look at this, put a little gauge on here, it is actually smaller than 10 gauge. So what do you think that is? 12 gauge in there? If you can imagine a big 4 or 2 gauge battery cable connected to these ends, it's going to heat up these wires. Anyway, get back to putting this together. Alright, I got the back on this inverter. It's converted from AC to DC input now. We'll flip the switch and see what happens. Everything looks good. Okay. Can you believe that? It worked. How about that? Oh, shoot, we're getting too high. Alright, I just cut the power because she went over 500 watts. I don't want to fry this thing out. It seems to be okay. It looks like I'm going to need a bigger grid tie. Well, that sucks. Alright, I did find a bigger inverter. This is a 1000 watt one that'll handle 36 volts. But change of plans. I'm not going to convert that one to DC inputs because I don't want to go over 500 watts into an outlet, because I'm going to have two of these set up for at night, one for each leg of the one. Before I do that, I should probably complete this test. Alright, I have with the small 10 gauge wire, I have 4 batteries hooked up. 2 are in parallel, or 2 sets are in parallel and ran in series. So it's going to come out to be 24 volts. Let's turn it on, see what happens. Alright, I guess we'll call it 354. It's settling down a little bit. 350 at 3 amps. 350 at 3 amps. 350. 3 amps. Alright, now I just have to hook up the 4 gauge wire. Alright, last test run here. We got the 4 batteries hooked up for a 24 volt setup, and I'm using the 4 gauge wire. We'll turn it on and see what this one does. Alright. $355 watts. Well, that's pretty much the same, right? Amps. Almost 3 amps. Watts, 351. 350. Let it settle a little bit, I guess. Amps. Well, it's about the same as 10 gauge, it appears. 350 at 3 watts. It's about the same. Doesn't seem like there is too much of any kind of loss compared to the 2 wires. Still go with the big anyway. And there is more of it. There's some really long runs here. I mean, when I do get it set, they're going to be a lot shorter. But anyway, this completes the run. And get a little shot of this. So actually, let me write these in here. It's pretty much the same. 353. There you go. If you want to look at these, just freeze the picture. Alright, I just ran this for 2 hours. When I started at 520, I was pulling 345 watts, and that's a load what the percentage of the batteries were. In the same configuration, the way they are here is the way they are there. Okay, 620 watts or less, batteries are dropping down. Okay, 720, same scenario, and the batteries are really down except for this one that says 81% here. That one is the Napa battery right behind the meter. Right now on this meter it says 76%. That's off of this battery here, and that's with everything disconnected. Batteries came back up, and there's what they came back up to. That's a 2-hour test run.